Hello. Yes. Hello and welcome to Rust Exercism track. I'm solving this parallel letter frequency task at 11:30 p.m. because, well, it's obviously a genius idea to start a hard level task at this time, but I'll do it anyway. Okay, and I have downloaded it and open it. Let's read readme. Welcome to parallel letter frequency on Exercism Rust track. Count the frequency of letter in text using parallel computation. Cargo bench. Let's try cargo bench. May not be used. So, they were right. I need Rust up, run, nightly, cargo bench. What does it mean for a benchmark to fail? I don't really understand. Oh, it's not implemented yet, so yeah, it's just throwing a panic at a function that is not implemented yet. Okay, let's look at the tests. What do we need to do? Frequency. What's HM? Some kind of a hash map? Yeah, that's correct. No text. One text. What does 4 mean? 4 should be the worker count. I see. So, what do they want to do? Many empty lines. Oh, so I can actually slice lines into pieces and send them to workers. Wilhelmus van Messuwe, ben ik van Duits en bloed, den vaderland getrouwe, blijf ik tot in den dood. En prins van Oranje ben ik vrij en vereerd, den koning van Hispanië heb ik altijd geëerd. Okay. Let's get to the task. Liberes. Count the frequency of letters in the given input. Ensure that you are using the given number of workers to process the input. Sure, why not? So, first of all, we need hash map. Do we have to do that concurrently? Can we share one hash map and just protect it with a mutex? I feel like that's what I'm supposed to do. Oh, okay. Who am I to argue with my intuition about what is wanted from me? Use std sync mutex. Right. Okay. My hash map is mutex new hash map new. Then, in the end, we return HM. Oh, what else do we do? Then we need to start the worker count of threads, and then we need to join them all. Oh, yeah, that would be something like use std thread for e in from 0 to worker count. Okay, yeah, let's do it in a stupid way. Let join handle is equal to thread spawn. Then what do we do to spawn? Right, and then we need to move into this. It's a good question. What do we need to do? Hmm. Would I be able to split the given input into n chunks and then move them in there? I think I might be able to do that. Let mute gh threads. Well, why not? Threads push join handle. Then for e in 0 to worker count, or rather for join handle in threads into header, join handle join, and then we just return the hash table. Yeah, that's obviously some other language started messing with my field for semicolons. Mismatch types. Why? Mismatch types expected. Found mutex. Does mutex have something like into inner? Mismatch type labels. Found result. Unwrap. I don't care. Okay, what happens here? So first of all, how do I split all of this into I see. Let work len is equal to given the input length divided by worker count plus at least 1. Then what do we do? Let work mute. Well, is there such thing as pop from the start? Put split what does split do? It takes a function, returns some kind of iterator, split at. That sounds like what we need. Can I also change split at mute, split first? No, I don't need split first. Split inclusive, split last, split. Do I remember correctly that there was a way, Rust slice, to splinter something from a slice and keep the rest in place? Is it even possible? Or am I confusing this with bytes. Okay, whatever. Don't I don't really in the mood to guess right now. Let's just do it the stupid way. Work input rest. Let's just say that this is input split at worklen. Um, mm-hmm. I'm wondering if it does the right thing. If it does what I think it does. But okay, so now we have work, and this work can be safely moved into the new thread, and in the new thread we can do something like what I would actually like to do. Oh, we still need a mutex, right? Yeah. We need to have this local hash table, hash map new, and it definitely needs to be mutable. Then what do we do? Then we iterate over the given piece of work. Oh, right. Yeah, let's just write it in a stupid way. For ln in work iter, for c in ln chars, for each character let's put it into the hash table. No, that's not how you do it. Entry by key C or default 0, and all this thing should be incremented by 1. Now, do they have a default for usize? I think so. Perfect. Type annotations needed for hash map. Well, they will not be needed once I do that. And what I do is I create a guard. I just create a guard lock, and this is hm lock result mutex guard. I unwrap it because I don't care. You only live once, and now you have a guard, and let's override it locally. And when it goes out of scope, it will unlock the mutex, and everything will be good again. So now let's do what? Let's say that we extend hm with extend the collection with the contents of an iterator. Does it make sense for... Oh, we actually don't need to extend. We will have to do this. For key, for C, number in H, is there such thing as items? What does iterator produce? Huh, well, it works. Perfect. HM entry at C or default plus equal to n. Binary cannot be applied to what? Yes, well, I think that's what I need to do. Yeah. Uh, okay. Mismatch type label hash. Why does it do that? Do I have to do this? Yes, I do. Yes, I do. Have to do this? Yes, I do. I have to do this. Yes, I do. Cannot mutate immutable variable hm. Well, obviously. Thank you, compiler. Type annotations needed for... Are they still needed? Really? Oh, well... Okay, please. Well, it must have some type inference conflict. Borrowed data escapes outside of function. Which borrowed data? Interesting. Use of a moved value. Oh, can I do it like this? Let mute hm clone. Can I clone mutexes? No method called clone. Well, oh, that's why they do it in arcs. But then why not? Okay, what do I need to do here? Node code actions available. Why? Use std. What is it called? Sync arc. Yes, that works. Now what happens? Borrowed data escapes out of function. Why? Okay, now I need an explanation for stupid people like me. Cargo check. Please, compiler, show me in pictures what I do wrong. Remove this mute. Well, yeah, it's hidden behind the mutex, why not? Unused variable I. Well, why not? Well, yes, it's hidden behind the mutex, so it doesn't need to be mutable. Borrowed data escapes. Yeah, and now we have the meat of the problem. Yeah, let's read into that carefully. Input escapes the function body here. Argument requires that the lifetime 2 must outlive static. Well, more than eternal life. Wow, that's something new in theology. Okay, let's call the lifetime of this reference to. Input is a reference that only valid in the function body. I see. Okay, I see. Yeah. So, what do we do? Well, it looks like I need scoped threads. And now let's learn something new. Scoped threads. Thread scope. So how do we use it? This is a closure that has some weird handle called s. Then we spawn a lot of things. Well, it's even better than I wanted. Well. Wow. I like this. I like this very much. Structured concurrency is just a very powerful thing. And now in this scope, let's do all of this crap. Threads push, join, hm into inner. Why not? And now they do not escape. And this becomes redundant because of the power of structured concurrency. So, yeah, we need to mutate input. So, who can spawn now? It is S who is able to spawn, and thus we have solved the problem of lifetimes. Cannot move out of an arc value move due to this method call. Well, okay, how does a thread scope works? It returns a t, which is returned by the inner function. So basically, if we do it like this, arc. What does to owned mean? Into inner HM. Well, okay, thread scope, and let's say arc into, no, let's do it like this. So first of all, let's keep it here. Then it is used by all of this thread pools thingy, and then after that we will be able to take the hash map behind the mutex wrapped in an reference counted pointer, and then if we unwrap this, that will give us a hash table wrapped into a mutex. And then if we do into inner again, we get we possibly get the hash map. And then we need to unwrap it again because we trust it to have the hash map inside. Now let's try it. Okay, cargo test. It fails. Why? No texts. It's panicked. Yes, because we cannot split here, and we need to be careful with splitting if we don't even know if worklen is available here. So what we can do here, first of all, let's do it like this. So and let's be very careful here. So first of all, we check if input len is 0, then we just break. There's nothing to do. If input len is less than work len, then work len becomes input length, right? And then we avoid the panic and only run the given number of threads, hopefully. Okay, let's unignore our tests. Ignore. Don't. It works. Don't. It fails. Right, because it must be case insensitive. What does it even mean to be case insensitive? So let's look at that. And what did just fail here? This. A must become lowercase. Yeah, that's what I missed in the specification of the task. So C in ln chars. Let's say that C is equal to C2. Oh, do we need to handle Unicode lowercase or ASCII lowercase? Does it matter? Does it really matter? Let's go for a fast one, And let's change it to Unicode if some tests start failing. Okay, now it passes the test. Next ignore. It works. Next ignore. It works. Next one. It fails. Why? Punctuation doesn't count. Okay, let's get back to reading. So, what is the exact spec of the task? Parallelisms by doing things in parallel. Okay. Create a function that returns the total frequency of each letter in a list of text and that employs parallelism. What do they call a letter? Is it a Unicode letter? Is it a Latin letter? Yeah, well, obviously. All of the world just uses the Latin alphabet. Yeah, of course. And aliens speak English in Stargate. Because, well, obviously. Okay. Let's stop venting and let's just do what they want to do. If what is happening here? To ASCII lowercase. If it is not true that is alphabetic, then continue. Well, it fixes the test. Perfect. Next ignore. It works. It works. It works. No ignored tests anymore. Okay, I think that does it. Exercism submit. Oh, one more thing. What was this incantation? Rust up run nightly cargo bench. Yeah. Let it bench. Who would have thought? Parallelization makes it faster. And yes, if you take a very small input, then overhead of synchronization just kills it. Yeah, that is what is expected. Yes, yes. Okay, let's go to the website, my iterations. Well, tests. Well, do I have any suggestions? No auto suggestions. Please enlighten me. What I can do better, please. Okay. Overview. And let's consider this solved. Okay, thanks. Bye.